Welcome everyone. It's this summer is different for pretty much all of us, right? And as most summers, I was expecting to be spending the summer doing data science for social good fellowship in person with a lot of people, seeing and then ideally attending the events and the program in the UK as well, and looking, and here's where we are, right? And I think it's all of us who are involved in these types of efforts there's a set of people who are waking up and realizing I'm wasting my life doing hedge funds or finance or advertising, and I want to do something more useful. And they're waking up trying to figure out what to do now. And then there are people who have been doing this type of work for many years. And the questions that we're asking is, what do we do now that's needed right now? How do we, we're working on different areas. So what changes now? And one of the things kind of that's changes now that Turing has been doing is exploring to see, how do these types of programs happen if we want to run them online, right? I don't think we have a good idea. I don't think anybody has any evidence that sort of hands-on, collaborative programs that are focused on both training and doing, sort of experience and learning programs, can be effective online. We haven't shown that in a distributed way, bringing people in from different disciplines, bringing people in from different parts of the world. So I'm really excited and curious how this turns out, and looking forward to seeing what happens. What I want to do, let me sort of share slides so that you guys stay awake. And let's see, 1 second. Yeah, so the Data Science Social Good Fellowship Program has been running for many years. We started about 7 years ago, and it's changed, evolved in different ways. And one of the things that we've tried to do is keep our goals and our values constant, right? And those are still the same. Right? So our goals have always been, how do we train people who are coming in from different disciplines, computer science, stats, engineering, social sciences, public policy, math, but care about the world, want to do something that makes things better. What is the best way to get them ready to do that? So that's been the primary goal all along. The second goal has been, how do we train organizations whose job it is to make things better, to help the community, to improve different aspects of the world? How do we help them understand the use of data and all the related buzzwords that I had in my previous slide? And then how do we do that while building a community that can work together, right? The programs that we've been running typically have been 3-month programs, and they're too short to actually change a lot, to be honest, right? It has more impact on the people involved than it does on the problem, because in 3 months, we're not going to solve poverty. We're not going to solve racism. And so our mission has been, how do we make even a small impact on those problems while we start building this community that can then continue to work together and tackle the bigger issues. So those have been the goals for the program. And the values that we've been really instilling in the programs are, one is that of openness. Everything we do is open. Every project is talked about publicly. Every project has code that's open source. And that's important because we want this work to not just be done in a corner and kept sort of secret, but shared, because it helps achieve the training and the community building goals. The work is also collaborative. It's when we work, and if you're noticing, when we work in an organization, we're not going in and getting a problem from them, solving it for them, handing it over and going away. It's a collaborative project, and that's where we call them project partners. we're partnering with them to do three things, right? We're partnering with them to train our fellows. We're partnering with them to help them understand how to do this better. And we're partnering with them to have an impact on the community, on the people that they want to help. And that's an important distinction between us. You know, sometimes these projects, when we talk about them, they might come across as consulting projects where there's a client, they give us a problem, we solve it, and we move on. And they're nothing like a consulting project, because our goal is not to help an organization. So you're going to hear, and I'm going to talk about some projects, and then the summer teams will talk about some projects. Our goal is not to help the organization, and this is, you know, this is not supposed to come across as we don't care about this organization we're working with. We very much appreciate and as them as project partners, but we don't care about helping an organization. We care about helping the people they're trying to help. And this organization is a conduit for us in order to have the impact that we want to have. Just like that organization has the same mission. The organization mission is not to be the most efficiently well-run organization in the world. Their mission is to help improve X, right? Whether that's you know, housing stability of people, whether it's public health, whether it's education, whether it's employment opportunities. That's their mission, and we want to help that mission that affects the people. And we very much care about doing it in an ethical way, and that's embedded in the entire programs that we do. So, you know, that's kind of the overall context, and typically sort of these projects and lectures and workshops, and this is how we do it, right? We'll do those types of activities, and I'm not going to go into that. This is just to kind of give you an idea of, you know, we've been running this program for a while. It's been changing its form a little bit. Typically, it's been sort of 20 something to 40 something fellows with about, you know, 10 to 12 projects over the summer. This summer is sort of one of the things we launched through. A lot of this was started at the University of Chicago, which is where I was based for the last 7 years. And then last year we launched a nonprofit called the Data Science for Social Good Foundation. And one of the things we're exploring this year, and that's what we're excited about partnering with Turing and Warwick, has been this DSSG X model of how do we have affiliate organizations in different locations that can run versions of their own program that are not the Data Science for Social Good Fellowship that we run, that's sort of fairly heavy weight and requires a lot of infrastructure and consistency. But how do we help organizations who are interested in the mission but want to try different versions of it? So this is kind of the first attempt at running this DSSGX program, and I'm excited about seeing what happens. So here's some, you know, it's actually, I was going to say a random list of organizations that we worked with over the last few years, but it's really an old list of organizations we've worked with. I haven't updated that in a little while. And one of the things we've been deliberate about is working across different types of problems, different types of issue areas: education, health, criminal justice, public safety, transportation, environment, energy, unemployment, poverty, conservation, whatever I'm missing, you know, infrastructure, urban infrastructure. So that's been one way of stratifying to kind of understand what it takes to solve problems in these areas, but also to expose our fellows to these different areas. The other one has been stratifying across type of organization: government, nonprofit, federal, state, local governments, international. So we've tried to kind of, and then geography, where we do these projects. They're fairly spread out. So what I want to do is kind of talk about a couple of projects that are relevant right now, that are either going on or have been done recently, and then really focus on one aspect of those projects, which is how do we think about doing those projects that result in kind of fair and equitable outcomes. Because often, let me actually start with some of the examples, right? So the types of, so there's a project that I'll talk about that's been going on for now about 3-ish years, a little over 3 years. And their project is with a county in the US, in Kansas, called Johnson County. And as you've probably heard, the US has a pretty broken criminal justice system. Um, a very, very, very large percentage of people go through jails and prisons, and they keep cycling through. And the depressing part is that a lot of those people who are going through the system, the criminal justice system, through jails, through prisons, have mental health issues, about half of them, a little over half of them, chronic health issues, substance abuse disorders, and those are often become the causes for why they end up going back to jail, getting arrested, getting booked. And so this county came to us and said, look, we've got a high recidivism rate. And we think that the root cause of that is the people are not getting access to the resources they need, the mental health resources they need, and would like to pilot a program where we have a small amount of resources we can devote. We can work with a couple of hundred people every month to provide them proactive mental health services. We already have some of these, but we don't do it proactively. We sort of go to them after the fact that they've been arrested. Can we be proactive? And because there's so many people who they could focus on, they asked us for help in prioritizing who should they do that outreach to. And so what we did, and so the first thing we did was kind of work with them to figure out what kind of data we would need in order for this to be effective, getting data from criminal justice, from policing, from mental health, to figure out what were their previous mental health needs, who they've actually done outreach to, data around hospital use, emergency room use. And we put that together to first see, can we identify individuals who are at risk of recidivism? And we found that we could actually do that fairly accurately. But that's interesting, but practically useless, because just because I can predict who's going to come back to jail, it doesn't mean I can do anything about it other than watch them come back to jail and have pretty bad outcomes. So step two was to see, great, we can identify who these people are going to be. Now, do the people we identify, do we think that their risk of recidivism will go down if we were to intervene through this mental health outreach program? And that was the part where we've really been focusing on for the last year and a half. And so we developed system strategy, one, to identify, and two, to figure out if they had any prior mental health issues. And then we designed a trial, a randomized trial that launched almost exactly a year ago, where the mental health team over there gets a list of people from us. They go out and they start doing outreach and proactive mental health, provide them services. And then every month they do that. And we get this data back. And so the trial is just finishing now. And now we're going to have to wait a year to see what their outcomes are. And the hope is that we'll find that the people we intervened on had a much lower risk of recidivism. So we'll find out 12 months from now. And there were sort of two goals for that trial. One goal is to just figure out, do the people we identify, can their risk be reduced? The second goal was, does that work effectively for different types of people? Maybe there are different types of interventions that need to be used for different types of people. And so this trial is also hopefully helping us understand who this intervention is effective for, and how would we design new ones for people it does not work for. So we're excited about sort of seeing the results of that trial, because that has huge implications on a lot of the criminal justice system, at least over here. I'll mention that, and there are several projects like that we've done. We've done some work in public health and identifying children at risk of lead poisoning and intervening early, or with schools around identifying students at risk of not finishing school or dropping out of school in different cities, in different countries. Unemployment, understanding predicting who's going to be at risk of not being unemployed for long term, and connecting them with skills training programs, other types of programs that can help them. So I'll describe a slightly different project that's again relevant if you've heard about what's been going on in the US around policing. And that's one project, again, we started a few years ago, around identifying police officers who have a high risk of doing horrible things, unjustified shootings and unjustified use of force, all of those different things. that you hear about. And again, the idea was very similar to other types of projects where taking the existing, we worked with several police departments to take their existing systems, evaluated them to figure out that they were mostly ineffective, developed a new one that was taking all this information about what we have about police officers, a department has about police officers, and identifying these officers who are going to go on to do one of these things that hopefully we can prevent. And the interesting there was that the what you find out is you find out what you find out in most of these types of projects is people who have done things before will do things again, and that's not necessarily interesting, but more importantly, it's not really preventative. You don't, if it says this person who's done these 4 shooting incidents is high risk of doing another one, well, it's too late. You haven't prevented those 4. 2, any intervention you design now is really not going to be preventative. It's going to be punitive. Suspensions, getting them on desk duty, those types of things are not necessarily preventative. And so one of the things we're looking at there is trying to earlier warning indicators. So for example, a couple of predictors we ended up finding as we were building the system that were predictive of kind of officers being high risk temporarily were things like repeated dispatches to domestic abuse cases, especially involving kids, repeated dispatches to suicide attempts. And so when an officer had a lot of those dispatches, when they were sent to those types of incidents, they became temporarily high risk of doing one of those horrible things. And that's a small, it's not, it's not all of them. It's a small subset of the officers. So this accounts for a small number of these incidents, but these are the type of incidents that are relatively easily preventable, where if you've already been to some of these and the dispatch call comes in, now the dispatcher can decide, oh, this person is high risk for this type of incident. There's another one officer equally far away or a couple more minutes away. How about I dispatch them instead? And can you embed this type of system into the dispatch system so that it's not a decision that's being made every time manually, but it's embedded into the values of this type of a system. So we have kind of the initial system, the one that predicts risk and puts it into the workflow for the internal affairs, for investigations and disciplinary actions, implemented. And so, but a lot of these systems, we sort of start from working around defining the problem, doing the analysis, building prototypes, doing these trials, and then helping implement these systems so that every project doesn't go there, especially most projects are initially prototype projects, and then we go deeper into some of them and spend a lot of time. So in this case, we did spend that time and work with these organizations to implement. So that system is now implemented into several police departments and being used in their daily workflow. So those are just some examples of projects. And in most of the projects that we do of this sort, basically one common theme, it's not much, probably half the projects that we've done, a common sort of theme is that an organization, government, nonprofit, is allocating resources. They have limited resources, unfortunately. And they're trying to allocate those limited resources towards people or organizations or locations that need some sort of help. It's kind of a benefit allocation problem. And in this benefit allocation problem, they're trying to do something to help those people, whether it's helping them stay healthy, helping them become educated, helping them get a job, helping them stay out of jail, helping, or if it's for an organization or for locations, it might be helping with housing safety or restaurant safety or office location safety things. So it's really allocating limited resources towards interventions that help those people. And one thing that's really challenging is that the way these projects get started, the way these organizations think about the use of data, machine learning, AI, all these different things, is that, oh, they can help us be more efficient. We have limited resources, we have so many people to help. How do we help the most people with the resources that we have? That's the framing a lot of them come in with. And that's not a bad framing. I think that's we've gotten used to this type of framing of, we have limited resources, how do we best use them to help the most people? And a challenge with that framing is that if we take the efficiency framing and help the most people, well, then we're going to help the people that are cheapest or easiest to help. And if we really prioritize the cheapest or easiest to help people, we leave a lot of people behind who are harder to help, who are more expensive to help. And that leads to a lot of inequities. Right? So if you only help people who are living in urban areas, then because they're cheaper to help, you have a dense location, you can put a single point of service and help a lot of people, but then you leave out people who are all everywhere else. If you only help people who are on, and sometimes it's explicit, sometimes it's implicit. Again, if you put service locations, if you're going out and doing outreach and you're providing proactive services, let's say the mental health services, if your services were if you were calling people in English to provide them with service, then you're only going to help people who understand and speak English. And that's not necessarily equitable. Same for if you're providing, and this happens way too often, if you're a government agency and you've discovered there's a thing called smartphones and you want to have a cool project that you can partner with Apple on, you're going to build some app that's going to be available for everyone using iPhones. And then you have to think about how many people that you're trying to reach have those iPhones. How many of those people actually know how to install an app? How many of those people know how to use an app? Those kind of things are it's very easy to build the app and talk about it and checkbox for innovation, for providing these digital transformation services. But the equity piece is the one that often gets left out. So what we've been doing in pretty much all our projects is, one, we have a strong component of thinking through the ethical issues, but then also in every project we'll do equity, bias, fairness audits before, even if it's a prototype project, even if it's not being implemented and acted on, both for training ourselves, our students, training our partners who are going to be doing these types of things. There is some sort of an equity, and the goal of all of these work, these projects that we're doing, is we want to make sure that we answer this this key question of how do we develop these systems. The larger question outside these projects is, how do we develop our AI, machine learning, data science, other buzzwords that have systems that can help make decisions that lead to fair and equitable outcomes. And there are two things that are, there's sort of two types of bolding here, right? One is help make decisions. Every project that I've talked about, none of those are autonomous systems. And those are all of these systems I talked about. None of them are online advertising systems where you're making millions and millions of micro decisions every second, or finance systems that are, again, making these trades automatically. The decisions are being made by humans. Somebody is trying to figure out how to help provide mental health outreach, and how to do preventative vaccines. So it's a human making a decision and our system is helping them. That's one. The second thing is, in all of these problems, the goal is not for the process to be necessarily fair, for the data to be not biased, for the machine learning system to be fair. We don't care about any of those things as long as the outcomes we reach are fair and equitable. So it's very much, the work that we've been doing is very much focused on the outcomes. And it sounds really simple and trivial. The reason I'm emphasizing it is that that is not the norm in a lot of if we're machine learning centric, then we're going to say, how do I make our machine learning models fair? And I would say, who cares if your machine learning models are fair? If those models are perfectly fair at identifying who needs help, and then the partner you're working with, again, goes and uses them to do outreach in English, you're going to get outcomes that are unfair. And it's not the fault of your model. but it's the fault of your overall system that did not think about the outcomes. It just thought about, my model is fair, so why do I have to worry about something else? And we can make that model as fair as we want, but we need to, it's not going to have an impact on what we care about. So that's the reason for kind of focusing on measuring the outcomes rather than the inputs, the process, the components. The components are useful and you want to look at all of them, but that's the thing we eventually care about. And so what we end up doing is kind of thinking through sort of where do these inequities, where do these biases come from as a first step. And it's unfortunate that it comes from too many places, right? The biggest one is the world. The world is biased, unfortunately. And that's where most of the biases come from. It's systemic issues in the world around, racism, for example. That's at least there in both of the countries. It's there in the US, horribly, it's there in the UK, and it's there in many, 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 many other countries. The second one is a little bit unintuitive and it's something in our control. But the second place in a lot of these systems the bias comes from is, I'm calling it intentional. It may not be intentional, but sometimes it is. It's the people like us who build these systems. We embed some of our own biases into these systems. For example, you might the example of, I'm going to use an iPhone because it's easy to code in. It's also easy to develop in, and have a partnership with Apple. Well, that's an intentional choice you made, and it results in downstream bias. Another one that happens quite often, which way too often, is system developers will choose what data sources to use. And they might say, I am not going to use that data source because I think it's biased. And usually it's I think is biased rather than I incorporated it, I did an evaluation, and I found that it was biased. It's more a starting intuition of, I'm not going to use race because that data, I think it's going to result in bias. And it turns out that's a horrible, horrible, horrible idea. If we don't use some of those attributes, we can't even detect if we are being biased. But that's a very common thing a lot of machine learning developers end up doing. The third is we make these systems way too complex sometimes. And that complexity means that we embed these biases that we don't really understand, we can't debug them. And that happens all the time, especially in sort of large engineered systems, right? I'm sure most of you have heard about all that. I'm not giving you any of the examples because we talk about them way too often around face recognition systems and chatbots and all these things, right? But one of the ones that Google had screwed up with searches for gorillas showing up in resulting in photos of Black people. The only way they could fix it at that time was just hard coded, because it was too complex to understand how to actually fix it and what it was doing. The next source is often data, because the data becomes a starting point for our analysis. We often take data as given, and again, that's not true in every field. It's more true, unfortunately, in machine learning, and hopefully it goes away very soon if we do better training. Is we sort of take data as a given. Like, this is the data we have. Let's assume it's great and use it. And pretty much most other fields using data don't do that. They think a little bit more, and I think we can learn a lot from those fields, which is, as a side thing, a key component, and one of the reasons for DSSG being across disciplines. So every year, on average, we do about a third of the students come from computational areas, a third of the students come from kind of stats, math, engineering, and a third come from social sciences. And a lot of the social sciences have really spent a lot of time thinking. They might, have other issues there, but thinking about, where does data come from? How is it generated? What are the different biases around sample bias, measurement bias? And I think machine learning is starting to get there, but we need to get there much, 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 much faster. Label bias is a really interesting one because that's really, really, really hard to correct. So an example of that is the police example I was giving. If we're predicting who's going to do something horrible, well, horrible is not well defined, unfortunately. And the way police departments do it is every time, let's say, an officer uses force or takes a weapon out or points a weapon or has an injury, they have to report it. Now, whether they report it or not, who knows? So that's a sample bias problem. But then once they report it, the police department investigates them. And the investigation results in justified or unjustified. Or somebody complains about a police officer, that they get investigated, the complaint get investigated, and it's either sustained or not sustained. That's the label bias. If you have a horrible and corrupt police department, they're never going to sustain any complaint. And there are many such departments. If you're a good department, you're going to sustain the complaints that need to be sustained. But we have to rely on them to give us this label that we then use to build our models to then predict what to prevent. And if there is biases, a set of biases in there, there's nothing we can do as easily, initially at least, to fix those. So that's something we have to be aware of and look at and build that process into the system to even detect these types of anomalies. And then, I'm not going to go into too much detail. I want to cover a couple other things, complexity of flaws in our methodology, of how we do things. For example, a really common thing, this is sort of going a little bit deeper, a really common thing we do is we link data together, right? So we do data integration, record linkage, matching, because we have to combine these things. And often in all these systems, we make somewhat arbitrary decisions on how to link two records together. Typically, these methods give you some confidence, like this record is the same as this person, and then we decide, oh, above this threshold, we're going to say link, below it, we're going to say not link. And we make mistakes. Sometimes we mislink people that are not the same people. Sometimes we miss the links between two people who are the same. Now that might seem like, oh, okay, it's just some error that I made, and I'll fix it, or everything has some errors. It turns out those are often systematically biased decisions. What happens is people who have long names with lots of consonants next to each other often have typos in their names in different systems, and they get missed quite a bit. They don't, and people with common names tend to get mislinked together. And so those then lead to when you miss people, then you sort of remove interactions around those people. So they might have had 6 encounters with the police, or they might have had 6 mental health instances, but you didn't link them together. So now you're only seeing this person only had 1. They must not be at risk of anything bad, so we don't need to help them, and you end up hurting them, right? So there are sort of these very simple things that we embed into our system. Another example that's really common is missing values. Every data set has missing values. And so what do most people do? Well, just fill them in with something, right? This person's height is missing. So what do? Like the most common thing is take the mean, take the median, something, and then fill them in, right? What's the big deal? Well, it is a big deal. So imagine your data is, again, same thing. We've got 80% men in the data, 20% women. We see data record for a woman and height is missing. So we just take the median or the mean and fill it in. And now we've made this woman look more like a man in the data. So then the predictions are going to be skewed towards, and it's easy to fix those things, right? You can sort of say, oh, well, you can just do mean across male and female. But that's a really simple example. We do a lot of this for much more complex ways. And these things are fixable. It's just you have to consciously think about what decision am I making right now in my machine learning process about, so for example here, right, what decision am I making? What data sources am I getting? How could they lead to biases down the road? How am I linking them together? How am I doing feature selection? How am I doing missing value imputation? How am I doing evaluation? Each step that you take in the project has downstream implications on biases, equity, fairness, on different types of people. And the idea is to be very conscious about it up front and at each step of the process. And so here, typically we think about the process as, think about what do we mean by achieving equity? How do we define equity? And it's not, in each problem, in each project, there's a different goal. There's a different societal goal that we're trying to reach. And it's really thinking about what is the societal goal? And that comes from talking to the organization we're working with, what is their goal? Talking to the community we're impacting around, what does equity mean to you? Who's being affected, who's being impacted? And then having this collaborative, these community discussions around reaching a consensus around, here's what we think equity means. and then detecting that, then turning it into a way that you can actually measure and detect that, understand the root causes, ideally improve it as much as possible. But then your system is going to have different types of biases. And so how do we mitigate the impact of those biases? And then monitoring and evaluating overall to see, are you actually, it's not a one-off effort, it's a continuous effort. So how do we continue to monitor and evaluate and still make sure that this is being achieved? That's kind of what in a typical project, those steps will go through. So I'll give you a couple of examples to kind of make this a bit more concrete, right? And so one of the things that when we talk about sort of defining equity, and we talk about how do we figure out what equity means in this case, or even when we're building a model for machine learning, what does it mean to be fair? It turns out there's a bunch of different things you could do. There's a bunch of different metrics people have proposed, and they're all useful and correct. At the same time, people have also proposed, there's a lot of theoretical work in this area. And a summary of the theoretical work basically says, oh, you can't get all of them. If you want A, you can't get B. And if you want B, you can't get A. And that's what the work says. The way that work often has been interpreted by policymakers and practitioners is it's being interpreted in two ways. One is, oh, we can't get fairness, so we shouldn't do machine learning. That's a horrible idea because that assumes that humans are so perfect and so unbiased that all the decisions they're making today are perfectly fair. And if we use these machines to help them, things can only get worse, right? So that's the assumption we're making there. We shouldn't use any of this because it's worse than humans. And it turns out humans are pretty horrible. Not the ones here, right? But in general, at making fair decisions. So the other the conclusion they reach is, well, I can't get fairness in all of these different things. So what do? I'm not really sure what to do. So one of the things we ended up developing to help that conversation with organizations that we work with is saying, yes, you're right. We cannot achieve every single definition of fairness, but we don't need to. For specific problems, specific interventions, specific goals, you only need to get a subset of these metrics. And so we developed this thing we call a fairness tree that kind of helps governments and policymakers and even practitioners sort of go through what are you trying to achieve and then figure out what metric do you really care about. So I'll kind of zoom in on a little piece of it. Right? One of the pieces of it says, are your interventions punitive or assistive? Right? Are you, which you shouldn't be doing, are you doing predictive policing and you're going out and arresting people preemptively? Well, that's horrible. Or you're denying them bail in a jail setting. That's horrible. If those are punitive, then who do you care about ensuring fairness to? Everyone without their actual outcome, people who do get interventions taken, or people who didn't need an intervention. And so, for example, this middle one, right? If your intervention is really horrible and it's going to hurt people who didn't need it, then you care about making sure that your false discovery rate, so all the people that you flagged, how many, basically a version of the false positives. You don't want disproportionate false positives across groups. On the other side, if you're helping people assistively, the examples I gave, then you don't want to miss people disproportionately, because if you miss them, you hurt them. In this case, you care about and if you can only help a small fraction of people, you want equal recall, or what's also known as sensitivity, right? And that's what we care about. So what we sort of help having these conversations from abstract equity and fairness to specific program level, intervention level, to specific metric that we can now embed into our analysis, and then think through how do we actually achieve that, right? So achieving it, the first thing we do is just being able to audit and measure these things. That's really, really, really simple. We know how to count and divide and calculate these metrics, right? But again, for policymakers and practitioners, we needed to build a tool that can help them do this. So we developed this tool a few years ago. This was about, I think, 2-3 years ago, that does bias and fairness audits, right? Where you'll go in and it's open source, and you go in, you say, I care about this, go through the fairness tree, pick a metric that you care about, pick the protected groups, and then it runs an audit and tells you where and if your model is biased and what types of people and for what types of these attributes. So that's the step one. Is that doesn't help you fix anything. It just helps you be aware of there exists these biases in my model. And that's helpful, one, if you're working with, if you're a government agency working with a consultant company who doesn't care about biases, but you should make them care about them. Or working with researchers or consultants. And this are sort of, a lot of government agencies are using this tool to audit these things before they accept them, before they use them. The second thing is, so this one is really, all you can do is audit, you're not fixing anything. Second thing is you're often in the machine learning process building many models. And the way we've been thinking about them is usually you sort of have some performance metric, which is a proxy for efficiency. Precision, recall, all these different things are some form of efficiency metric of how many people am I getting to. And you can look at these models as, well, yellow one is really good, I should use the yellow one. And if you start thinking about it as a different dimension of, well, there's also bias, you might still choose performance if that difference is not dramatic, but you might end up picking this one here because you can gain that extra reduction in bias for very little sacrifice in performance. The point is sort of like you want to be consciously thinking about it. It's not a one-dimensional problem. We think about other things. How efficient is it to run? How easy it is to update, maintain? How explainable is it? And bias is another one of these very key primary metrics that we want to embed in there. But it gets trickier, right? So here's an example. This is a project. These are all the dots are different models that are built. X-axis is performance, right? So this is precision, positive predictive value. Y-axis is bias of one type, false discovery, right? And so if you notice here, I have a choice at the very end. There are two models that have really high performance, and I can pick the lower one without sacrificing anything. I just have to look at it in this way. Or I might even go to this one, right? But that's one type of bias. If I was looking at a different bias metric, and that's where people get paralyzed, is, well, if you cared about this one at the bottom, you might not be able to reduce bias without dramatically giving up efficiency. And then it becomes a policy question. What do we care about more? How much do we care about this efficiency? What's the extra cost of equity that we're willing to pay? And that's a back and forth policy question. And an example of that policy question, I'm going to skip through this example. An example of the policy question that we did recently was in a project with Los Angeles in California in the US. And this project was that they have a city attorney's office that's in charge of reducing the number of people who get arrested for misdemeanors, or like small crimes. And again, like everything else, people keep coming back. And the hypothesis there again was there are people who have unmet needs that leads to them getting arrested, that then they go to jail, and then because they don't get met, they come back and keep going. And so their goal was to design programs that would, different intervention program, connecting them to social services, connecting them to other things that would prevent them from coming back rather than sort of arrest them proactively. And so the idea here was that they said, well, if we typically, the reason we can't do this for everyone is because it takes a lot of time to prepare these case files. And if you could tell us who's going to be likely to coming back in the next month, we could prepare the case files, prepare these connections, these interventions, and then be ready if they show up, so that we can connect them with the programs that they need to be connected to. And in this case, when we built our initial model, the initial model was optimized for overall global performance on the 150 people that they want to target. So basically efficiency, right? Now this is kind of the recall, that the efficiency we got, right, is everything was about the same except other was a really small percentage, but Hispanic was much lower than everybody else, right? So then we had three options, right? One option was we keep the program as it is, and we just build what we were building. Second, and that's sort of what we had. Second was that what if we helped people in equal proportion to their needs? What that would do is reduce overall rates, but it would keep the disparities constant, right? And so if we said we're going to help equal numbers of Hispanic people and white people, it would reduce these, but it would just keep the disparities constant. The third model would have been to help people proportional to their actual needs, and that would reduce the disparities. And we could do it in two ways. Like we could keep the current resources, 150 people, or we can say, well, no, there's an extra cost of efficiency, of equity, and we would want to help more people of a certain type and increase the resources. And so what we did was, I'm going to skip through some of this. We kind of gave them, the conversation we had with them was, what is your actual goal, their policy goal? Is it reduction in recidivism for everyone? That's sort of efficiency. Is it equal reduction for everyone, which keeps the disparities? Or is it equal recidivism rate for everyone down 5 years, 10 years from now? And if it's number three, which is what we really should be caring about, then each of these goals requires selecting and optimizing for a different metric. And once we have this conversation took a while, right? This is almost a menu option of option number one, option number two, option number three. Here's the cost of option number 1 and 2 and 3, and here is the outcome you're going to achieve, the societal outcome. And then you back into the machine learning stuff. And so they ended up kind of choosing, I'm going to skip through this. Basically, here were the 3 options we presented to them. We said option number 1 is it's going to be 73% efficient, and it's going to give you the most reduction, but worse outcomes for Hispanic people. Option number 2 is going to be 2% more expensive, will preserve the disparities as they are now, but reduce them for everyone, and it's going to cost you 2% more. And the third option doesn't cost you anything extra, but actually reduces disparities down the road and is more effective for Hispanics who have a higher recidivism rate. And so they ended up picking, luckily, and obviously number 3, because the cost was so little. But that's the conversation we had to have around the policy goals, societal goals, around what do we care about, and then giving them these choices that were not, what metric do you care about? It's really, here's the societal outcome, here is the cost, let's decide what we want. So that's an example of sort of a project that, going from a conversation to values, to metrics, to models, to all the machine learning stuff that we do. So it's just more of that. So I want to sort of, I know I've gone longer than I should have, but kind of, so the summary is really, we're at a point where we're seeing that, a lot of the tools that we have can help us create personalized policies that are much, much micro, right? The examples I was giving were very micro policies, not macro policies. And traditionally, they've been focused on kind of being more efficient and effective, but they have the potential to make things more equitable. And I think a lot of us who are doing sort of social good, it's great that we're doing that, but we have to be now much more intentional and explicit about our societal goals, and how do we go from this value conversation that doesn't usually include people like us who are building these systems, that kind of happen somewhere, but we need to be part of them because we're the ones actually implementing them, and then turn those values into actionable methods and tools. And what we found is that working with governments, nonprofits, and communities is really a very effective way to, one, understand the needs, but also be part of this process to create solutions that are more community driven, that are values driven, so that we can have the impact that we're all trying to have. Because that's why we're doing this, right? It's not because we want to make money and get rich. That's what our sponsors do. So we let them do that, and we do the useful part to have the impact we want to have. So thanks for listening. I don't know how much time we have, but happy to take questions either now or also my email. A lot of, I'll skip this one. I'll keep that. Take a look at this if you're interested in volunteering type things for this type of work. But my contact is my first name at CMU. Happy to take questions if there's time now.
how can we reach a solution when the data is available, the ML model is useful, but the decision makers does not seem to care about this?
Yeah, that's a longer. Yeah, I mean, I think the question there is, what does the decision maker not care about? Using the ML model, or using, or doing what, or making their decisions better, or the fact that they could make their decisions better if they use data. I think that's part of it to figure out, is what is the, what is the challenge. Often it's either it's not either there's a political issue there, where they want to make the decision they want to make, and any evidence you give them, they're not going to change, which is a different issue, or it's uncomfortable. It's sort of, being uncomfortable with new things that they don't understand how they work, or because they've read in the media that these things are horrible and biased. And so I think it's really spending time understanding what the gaps are, understanding their needs. Like when we work with these organizations, we don't go to them and say, hey, we have machine learning, we can give it to you. We try to understand their problem. We start with, what is your goal that you're trying to achieve? We have this whole scoping process. What actions do you take today? How effective are they? What are you doing today? And then we go in with saying, well, here's something we can do that's better. And it may not be better. We might find out that what we do, it doesn't improve things. But I think it's really trying to understand their problem, and in some cases people will still be skeptical because they don't understand what's going on, in which case our job is to try to convince them. But I mean, we're also hoping that, as one of the things that a lot of us have been involved in is programs that do train policymakers and people in governments around the use of these types of technologies. And I think that's important because they need to understand broadly, they're not educated in these types of things. And so there's a longer answer, but I'll kind of stop here.
Hello, thanks for the awesome presentation. Can I ask what you think economists, or what role you think economists contribute to these data science projects? And that's from Jackie Lee.
Retrain themselves. Oh, sorry. I mean, I think every discipline has, every discipline that uses data of some sort, right? Stats, and engineering, and math, and computer science, and machine learning, and econ, and other social sciences, sociology, and political science, has a role to play, but not exclusive. Like no discipline, all these projects that we've done, most of them have involved some combination of all of these. Most of them involve some economist, some policy person, other social sciences, stats, machine learning, computer science. Specifically, I think the intersection between social sciences and machine learning right now is, it's getting more active, but it's still very underdeveloped, both in terms of our trainings. Very few people learn both things, and each discipline thinks they're self-sufficient at solving any problem in the world. And I think that's probably the biggest sort of issue right now at that intersection. And so just working together, computer science is coming around to dealing with issues of causal inference. Economists have been there for a long time, but then there are other problems that machine learning brings in. There's a lot of really good work going on. And I think in all of these areas, putting that together, sort of say, well, yes, we want to do, we want to scale, we want to do a lot of these prediction type things, but then we do want to do behavior change and experiments in causal inference. So how do we couple these things together? And how do we think about a lot of these questions? And so it's an active area right now. And I think, if you email me, I'm happy to sort of point you more to things as well.
Thank you. The next question is from Sandeep. Of all the 60+ projects, how many can we say actually made a real change/transformation? And when it did work, what are the common challenges and what lessons were learned?
I mean, the easy answer is all of them made a real change and a real transformation. Otherwise, we wouldn't have done any of them. And I'm not just saying it because I have to say it, but actually I mean it. So if you remember that the goal of these projects is not solve transportation, solve poverty, solve racism. The goal of these projects is, number one, train the students, train the fellows, train the partners, build the community, and also to have an impact on the problem. But the projects that go on for 2 years, 3 years, have a much more deeper impact on the problem. The project that go on for 3 months, very hard to have the deeper impact on a problem in that time. So we've kind of set up these projects to have at least make sure they have the first impact, which is the training impact, because that's the impact that's going to continue to scale as the fellows go out and do other things. Same for impact on the organizations, because they learn how to do this. And then the impact on the project, on the specific problem we're solving, happens on as you can guess, a smaller number of projects. And part of it, the reason some of the projects that don't go on forever or don't go on longer, there are typically 2 or 3 reasons, right? One is that we find that there wasn't that much potential in there wasn't the right data available. The organization didn't have the infrastructure to actually implement, maintain, and scale this type of thing. Or the bigger issue is often funding, that we don't have the funding to continue these projects, right? We might do them in 3 months, but then it requires another 2 years. And there isn't a set of resources available to actually continue. So all of the above. So some of it is what somebody asked earlier around, I have a solution, but the decision maker doesn't want to use it. Right? That part of it is culture and training, and part of it is whether it's the right solution. Part of it is whether we have the resources to push through with that.
So next question is from Jürgen from the University of Warwick. His question is, you can only find biases that you are looking for. It may be obvious in some cases what biases to look for, but in other cases, it might be very hard to understand what biases could play a role. How do you identify the biases to look for?
Yeah, that's a good question. I think it's a more, there's a theoretical answer for this, and then there's a practical answer for this. So I think Jürgen can probably give the theoretical answer himself, because he'll be better at it. The practical answer is I don't really care about looking for biases, right? Where the point I guess I was trying to make is we can have this infinite search for biases, and that's great. We can keep looking and we'll find more and more biases of some type. I think the question is for us, if our goal is to reduce sort of bigger inequities that are happening in the world, you can sort of, basically the idea is how do we measure the outcomes and the large inequities that are happening? And then what do we do in our pipeline that reduces them? So that's kind of how I think about these problems, is measuring the outcomes and then not going in and searching for biases in my machine learning model, because that could be totally useless, is try to identify which things do I change that will have the most impact on the outcome inequities, right? So let's say I'm trying to figure out this recidivism rate. If I'm seeing difference in recidivism rates, I don't have to search for that. I can measure that big difference so you can kind of take criminal justice, you can take health, take healthcare. If we're looking at inequities right now in COVID-related complications, so what types of people are more at risk of complications given that they got infected with COVID, or what types of people are more likely to get COVID? That data-ish exists, right now, not so much because of all the biases in testing and diagnosis and all that stuff. Then the question is, how do we look at our analyses to figure out what things to fix in order to fix that? So that's kind of how we think about this, is not looking for bias, but kind of looking for what can I do that I can focus on the outcomes. I know I probably didn't answer that well, but we can talk offline.
Okay, I think there is maybe a clarification from Sandeep.
Yeah,
that's
a good. Go ahead, Mike.
Where's the question?
Yeah, so the question is, often I mean, so the specific thing here is that, how often will these types of systems actually solve the problem? It's kind of the summary of the question. And
Yeah.
that's how I ask the question is, how are what we're doing actually solve? Will this have, prison reform? And the answer is probably not. And so this example I was describing with the police project, that project does not solve racism. That project is helping a police department who wants to fix itself, give them a tool to embed into their workflow that helps them be more accountable. That's a very small piece. It's a useful piece. I would say it's a necessary and critical piece. If you are a police department, you should have a system that holds your officers accountable, gives you early warning if they're going to do horrible things, and gives you the tools to identify those officers and ideally prevent them. But this is not the tool you install to say, I fixed racism, right? That's something that's more systemic, that's process, that's how you hire your people, how you recruit them, train them, promote them, set up your police department. Machine learning and AI, and they might be useful a little bit in there in monitoring it, but it's not going to tell you your value system. It's not going to tell you that you should remove these things. That's going to come from the community, from the people. So Sandeep, absolutely agree. Like, a lot of these projects that we do are identifying symptoms and prioritizing these limited resources to help allocate them more equitably, more effectively, but are not necessarily tools that you can implement now and they create systemic changes. That's a separate thing, but it doesn't mean that we shouldn't do these, right? These have impact. These have pretty big impact in many cases, but for systemic issues, you're not going to use these types of tools. You kind of need a much more holistic approach. So that's unfortunate, but true.
And this will be the last question, I think, at the time. And it's from Jen. When presented with a problem such as the targeted intervention issue, where changing the policy to allow more time to gather information you need, so you only need to investigate targeted intervention methods for people who need them, or to use data science to make, how do you decide whether to fight for bigger policy change or to use data science to make your estimates and possibly waste resources investigating people who never get arrested again?
Yeah, I mean, very similar answer, right? I think those are all really good observations. Is when do you decide that you need to really focus on the bigger thing, and when do you try to kind of micro optimize these things? And I think the way we've worked so far is the smaller things are a way for us to understand the problem, to build a relationship with the organizations who have access to this data, because a lot of this is not public, and so help the ones who are progressive, they want to improve, help them improve what they're doing, because they're going to, whether we like it or not, they're going to continue doing these things. They're going to continue to allocate resources to do these interventions. If we don't help them, they'll do them badly. If we help them, we think they can do it better. But that's not the end goal, right? So that's the starting point. And then there is sort of this, if I was a company doing this with my mission to fix this problem, I would take a slightly different approach. But I sort of have dual goals, right? I also have a training goal, because I think that we can have a much bigger impact by doing this work while training the people we're training, because of the scaling factor. So that's kind of the balance, that we're doing, is we're doing solving the problems now, both to train people, but also to kind of show them what's possible. And then the longer we work with these organizations, the bigger systemic changes do happen, right? So in many organizations, they've changed how they were doing this, but that wouldn't have happened if we had just gone in there on day one saying, you should change the whole thing. You should just destroy the system and start again. So I think it's, at least our approach has not been destroy everything and start again. It's start understanding the problem, start helping them, because every day you don't do that, you're hurting people, right? Because they're still taking those interventions, they're still hurting people. So if we can start fixing that now, then we can get to the next step, which we do get to in many cases. That's not the only approach, and that's not, happy to sort of discuss, and it's not something we know, we are sure that it's the best approach, but that's the approach we've been taking right now, is start with solving the smaller problems and then move towards sort of bigger systemic change as we get more evidence-based, as we get the data to show that it's actually there's a better approach there. So those are all long conversation, discussion questions that unfortunately I'm giving unsatisfactory, very short answers to.
Sorry, thank you for answering all the questions. Just before we wrap up, so I'm a data science outsider in a lot of ways. So I think the way I view the DSSG and the program in general is that, from this perspective, that we have a welfare state. It's not going anywhere, but we are developing the tools to accurately measure what that system is doing and how it's affecting people. And through programs like this, we're developing the leaders who will be able to use these tools. And right now, obviously, there's going to be some pushback because not everybody understands what's happening. But without that understanding and doing projects like this and working with partners like Ofsted and the Ministry of Education and police departments to educate them on what it can do and how it can help them, allow us to penetrate further and further into the politics of policymaking.
Yeah, much better answer.
Thank you, Rayid. Thank you for the participants for preparing their presentations. I think you guys can hear my street. Thank you for all of the attendees. If you have any questions, we have an email. I think Rayid posted his email in the presentation, which will be made available. And you can check out turing.ac.uk events for further events about DSG and Alan Turing Institute in general. Thanks.